let's find a confidence interval for a proportion. So here we want to find the proportion of adults in a certain area that are parents. We have a sample of 600 residents that are adults, and there's 210 kids. And so let's check it out. So I'm going to use StatKey to run a simulation. I'm looking for a confidence interval for a proportion, and I want to edit the existing data with my 210 out of 600. That gives us about a 35% rate of people being parents. We want to then resample based on that one. So here's 1,000 different samples. So this is, again, a sampling distribution for proportions. Every one of these dots right here represents a new sample based on the reshuffling parents and kids. So if you scroll around, you'll see there's all different proportions over here. So I'm not on the edge over here. If you look on the right, I have about 0.385 is the proportion. The original one we started with is 0.35. And usually I like to generate more than 5,000 samples, 6,000 or so. And we're going to throw a two-tail analysis on this. We've got 95% of the samples in the middle of this sampling distribution. So again, a sampling distribution is just a distribution of a bunch of samples. So essentially what we've simulated here is going out and generating 6,000 different samples, each of size 600. And sometimes we find we have a lower rate of parents, 30%, sometimes a higher rate, around 40%. But based on the original sample and then simulating this over and over and over again, we think that with 95% confidence, the actual percent of adults in the region that are parents is somewhere between 31.2% and 38.3%. In this case, we wanted a 90% confidence interval. So all we have to do is change that center percentage from 95 to 90, which is 0.9. And now we find we're 90% confident that the actual percentage of adults that are parents is somewhere between 31.8 and 38.3. So we've got our 31.8. Did that correctly? And 38.3. That's decimals. Click the submit button, which allows us to check our answer, and I got them both right. And so again, we found a confidence interval for a proportion. And there's a couple ways we can think about that as an interval. And again, because we're doing simulations, the answers could vary slightly, but they're going to be in roughly the ballpark. So here, the my other math said it's going to be somewhere between 31.8%, 38.2%. That puts us with a central guess at the percentage of about 35%. Our margin of error is about 3.2%. Again, this is using sampling distributions and simulation to find a confidence interval for a proportion. Thanks. Do good math. Have fun.